Acids and bases are two types of compounds that do very specific things in solution. They also react with each other in a really specific way. So we're going to start here with some acid and base definitions, talk about how they react, and that's about as in-depth as we'll go with acids and bases for general chemistry. We will go much deeper in second semester. We will primarily use the Arrhenius definition for acids and bases in this semester. And with the Arrhenius definition, that means an acid is something that produces H3O plus in solution. Really, we also call it H plus in solution, but H plus does not exist completely by itself. The H plus that comes from the acid will attach to a water molecule, and the result is H3O plus. An example of this is nitric acid, where the molecule is the nitrate polyatomic anion with an H attached. In solution, when this dissolves, it is split up into H plus aqueous and NO3 minus aqueous. You can also, and it is perfectly correct to show the HNO3 reacting with one water molecule to produce H3O plus and NO3 minus. A base produces OH minus in solution. The bases that we will see, especially right away, will usually have a hydroxide polyatomic anion in the formula. So sodium hydroxide is a great example of an Arrhenius base that when it dissolves in solution produces Na plus and OH minus aqueous. When acids and bases react with each other, we call it a neutralization reaction. Now, the word neutral implies some things about pH, which is how we measure how acidic or basic a solution is. We are not going to deal a lot with pH in this class right now. Neutral implies that it is neither acidic nor basic. You'll find that that's not perfectly true, but we use the word neutralization here nevertheless, meaning I took an acid and a base and reacted them with each other, and we kind of got rid of the acid and base by producing water and a salt. So a neutralization reaction definition is an acid reacts with a base to produce salt and water. Of course, an example, the molecular equation. If you combine a solution of hydrochloric acid with a solution of magnesium hydroxide, hydrochloric acid is going to produce H plus in solution. Magnesium hydroxide will produce OH minus. So the neutralization reaction is really just swapping partners. And it just so happens that when you swap partners, one of the products is water, right? The H plus from the acid, the OH minus from the base makes HOH, which is H2O. And then the other product is the salt that's left over from the cation and the anion that were paired with the things that made the solution acidic or basic. In this case, that would be magnesium chloride. That's our product. And in this reaction, if we were to go through and turn it into a net ionic equation, the net ionic equation is just the formation of water. H plus OH minus gives you H2O. This would be a really great time to practice this if you want to pause this video and take the molecular equation and turn it into the net ionic. And also identify the spectator ions. A subset and additional type of reaction that we will need to deal with are gas evolution reactions. And we're dealing with this now because it affects what we write when we write net ionic equations. And I mean, in general, like how we label the things that are products. So we use the solubility rules to identify things that are solids and things that are aqueous. And then the other things, anything that forms a gas, will be in this list. So there are some gases that form directly and hydrogen sulfide is an example of this. If you were to combine a solution of sulfuric acid and a solution of lithium sulfide, when you swap partners, the products would be hydrogen sulfide and lithium sulfate. Hydrogen sulfide is a gas, and if you were to mix these two things together in the lab, you would know that you formed a gas because you would see bubbles, and in this case, hydrogen sulfide is stinky. It's the rotten egg smell. There are other gases that come from intermediates, and what this means is that when you do a reaction, when you swap partners, if you form any of the intermediates, you should not leave that compound written the way the intermediate is written. You should instead turn it into the gas that's listed. So if you form H2CO3, what will happen in solution is that this will turn into water and carbon dioxide gas. H2SO3 will turn into water and SO2 gas, and NH4OH will turn into water and ammonia gas. This means that when you write a net ionic equation that forms any intermediate, you must, just for a little emphasis here, you must turn it into water and the gas that's listed as the final product.